Hi, I'm an old guy and I do maths. We have an interesting problem here. We have the graph of the function of x here, and we have points noted here which are the turning points of that function. 3 of them. This is a quartic of some description, and we are asked to find where the derivative function is equal to 0, less than 0, or greater than 0. Now, those of you who understand what a derivative function does and what it tells us will get this in a few seconds. But the point of this video is to explain what's going on. Now, this is our original function, the function of x. The derivative function tells us what the gradient of this function is at any point that we choose, simply by substituting in the x value of this function into the derived function. Right. So, if we are looking for where the derived function of x is equal to 0, we're looking for where the gradient on this thing is equal to 0. And that is here, here, and here. The turning points. So, we can say that the derived function of x is equal to 0 at -3, 1/2, and at 4. And that's what x must equal. Now, what about the other parts of this? Well, if we draw a line here to illustrate what the gradient looks like, those of you who've seen linear equations, and by the time you're looking at this you should all have seen those, you would realize that that gradient is positive. There's another positive gradient over here. And so the positive gradient, where the derived function of x is greater than 0, is in these places. Here, it's negative. So taking this in order, where is the derived function of x less than 0, i.e. negative? It is negative between, so just let me get this written, 0, meaning it's negative. X must be, we're looking for the negative, it must be between -3 and 1/2. So it's negative there. And x also has to be greater than 4. These are the two positions on this graph where the gradient is negative. Now, the last one, f dash x is greater than 0, we're looking for where it's positive. Now it's positive here and it's positive here. So x must be less than -3 because it's all the way down here to negative infinity, and x must also be between 1/2 and 4, and those are the conditions that satisfy each of these. Now, very quickly, if I were to draw the derivative function, it would look a little bit like this. This is just a very rough impression. -3, 1/2, you can see how rough it is, and 4. And what you see from this is that where x is less than -3, the value of this is positive. So that satisfies this. It also satisfies this, where it is between 1/2 and 4. And where it's negative is between -3 and 1/2, which you see there. And where it is equal to 0 is here, here, and here. this derivative function graph tells us what these turning points are. Okay, well, I hope you found that useful. If you did, please like and subscribe, and I will see you next time. Bye.